Lab 3, Black Hole. The objective of this lab is to use the motion of the star to determine the mass of the black hole and analyze the relationships between various forces and the changes in momentum. Using Newton's law of universal gravitation and the connections between the different F-net components and the change in momentum components, I found the average mass of the black hole to be 1.8656 times 10 to the 35th kilograms. The two fundamental principles that are applied in this lab are Newton's law of universal gravitation and the momentum principle. The momentum principle is in the form dp dt is equal to change in momentum over change in time is equal to F net. Newton's universal law of gravitation states that there is a force of attraction between all masses in the universe. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. First, in my VPython code, I assign the given position of the black hole, the radius of the star and black hole, the mass of the star, and set the time between the data points to 1 day or 86,400 seconds. The first while loop is used to compute the velocity of the star during its trajectory around the black hole using the x and y components. The second while loop is used to calculate the net force from the motion data. The initial velocity and final velocity are defined here. These velocities are used to find the initial and final momentum by multiplying the star's mass by its velocity. From these first two equation sets, I'm able to find the change in velocity and the change in momentum. According to the momentum principle, dp dt is equal to the change in momentum over the change in time, which is also equal to F net. Next, I found the direction of momentum, which is p hat, and the magnitude of dp dt. These are multiplied together to find dp dt parallel, which is the same as F net parallel. dp dt parallel and dp dt perpendicular sum together to make dp dt. Thus, to find the perpendicular component, I subtract the parallel component from dp dt. Similar to before, dp dt perpendicular is equal to F net perpendicular due to the momentum principle. I used Newton's law of universal gravitation to calculate the net force acting on the star due to the black hole. Here I manipulated the universal law of gravitation equation to solve for the mass of the black hole. The universal constant g is 6.7 times 10 to the negative 11th, and here is the equation written in Python code. I also used an error scale of 1 times 10 to the negative 18th. When I run the code, you will see F net perpendicular, F net parallel, and F net shown by the arrows. As the star moves toward the black hole, the distance between the star and the black hole decreases while the gravitational force increases, which keeps the mass of the black hole relatively constant at 1.8656 times 10 to the 35th kilograms. In the model, the red arrow represents the component of the net force that is perpendicular to the momentum, points toward the center of the kissing circle, and turns the object in a new direction. The black arrow represents the component of the F net that is parallel to the momentum and changes the magnitude of the momentum. The yellow arrow represents the net force, which points toward the black hole and is the sum of F net perpendicular and F net parallel. According to the momentum principle, F net equals change in momentum over change in time, which is dp dt. F net is the sum of all forces acting on an object and causes changes in the observed motion. The change in momentum over change in time is caused by the net force. The net force is the cause of the star's motion, and dp dt is the effect. dp dt parallel and perpendicular are numerically equal to F net parallel and perpendicular, however, differ conceptually in the same way as just described. Because the new black hole was placed in the same location, the observed motion of the star remains unchanged. The mass of the new black hole cannot be calculated. Using the equation for Newton's law of universal gravitation to find the new mass of the black hole, the location is the same and the motion is the same, thus the net force is going to be the same and therefore the mass will be the same. I applied the momentum principle in Newton's law of universal gravitation and used VPython with the appropriate equations in the code in order to calculate the force components, the magnitude of the force, and the mass of the black hole. I found the mass of the black hole to be 1.8656 times 10 to the 35th kilograms.